Newton's second law, general form part 2 formula F equals dp, dt force is equal to the rate of change of momentum. This is the most fundamental form of Newton's second law. It is valid even when mass is not constant. The direction of force is always the same as the direction of change of momentum. Newton's second law, constant mass formula F equals ma. When mass remains constant, force becomes the product of mass and acceleration. For a given force, a body with larger mass produces smaller acceleration. For a given mass, increasing force increases acceleration. Acceleration always occurs in the direction of net force. Net force formula F_net equals sigma F. More than one force can act on a body at the same time. The actual motion of the body depends on the vector sum of all forces. Forces acting in the same direction are added, while forces acting in opposite directions are subtracted. If net force is zero, acceleration becomes zero and velocity remains constant. Weight formula W equals mg. Weight is the gravitational force acting on a body. Here, g represents acceleration due to gravity. Weight depends on gravity and can change from place to place, while mass remains constant. Weight is always directed vertically downward. Normal force common relations on a horizontal surface N equals mg. On an inclined surface N equals mg. Cos theta. Normal force is the force exerted by a surface on a body in contact with it. It always acts perpendicular to the surface. Normal force is not always equal to weight and adjusts according to the situation. Spring force formula F equals minus kx. This law is known as Hooke's law. Here, k is the spring constant and x is the displacement from the natural length. The negative sign indicates that the force always acts opposite to the displacement. Spring force is a restoring force that tries to bring the system back to equilibrium. Tension in a string relation T1 equals T2 equals T. In an ideal string that is massless and inextensible, tension remains the same throughout. Tension always acts along the string and can only pull, never push. Connected bodies condition A1 equals A2 equals A. When two or more bodies are connected by a string or pulley system, their motions become related. The magnitude of acceleration is usually the same for all connected bodies, although directions may differ. Free body equation formula sigma F equals ma. This equation is applied after drawing the free body diagram. All forces acting on the body are resolved along chosen axes. The equation is applied separately for each direction. Without a proper free body diagram, this formula cannot be applied correctly.